Hello friends, today we are going to discuss about magnetic force on current carrying wire. Okay, suppose we are consider a wire of length L in which having number of electrons E. Okay, and which is put in the uniform magnetic field B. Okay, so that electrons are moving with velocity V bar. So the direction of moving electron is this, and the direction of moving current is this. Okay. So in this, according to our last phenomenon, we have discussed that the magnetic force due to the moving charge is F bar is equal to Q in bracket Vd bar cross B bar. So we have to write in the scalar form Q Vd B sin theta n cap. N cap is the unit vector. Okay. Then we know that the Q is equal to I by T, and according to this, T is equal to what for moving charge? Vd is equal to L by T, distance upon time, velocity. So T is equal to what? L by Vd, means distance upon velocity. Okay. So according to this, charge is equal to IL by Vd. So we have to put this in equation first. So this is the equation first. We have to put the equation second in equation first. So according to this, magnetic force is equal to what? IL upon Vd into Vd B sin theta n cap. So Vd going to cancel. Remaining is Fm is equal to BIL sin theta n cap. So our magnetic force is in vector form. Fm bar is equal to I in bracket L bar cross B bar. Okay. Force due to arbitrary shape of wire. If shape is irregular, at that time what should we have to do? We have to take smallest element, length of smallest element. We have to put wire in uniform magnetic field. So for that smallest element, force is what? dFm bar is equal to IDL bar cross B bar. Okay. So we have to take integration of that. So Fm is equal to, for total arbitrary shape of wire, we have to take integration of only dl bar, because I is constant and B is constant. Only length of conductor is going to change. So this is all about magnetic force due to current carrying wire. Okay. Next, another equation we have to see, that is after this we are discussing that instruments. So instruments which are depend on magnetic field. So instrument depend on magnetic field is galvanometer. Okay. So how the galvanometer is depend on magnetic field, we have to discuss in this topic. So there are two types of galvanometer. First one is permanent magnet moving coil, PMMC, means permanent magnet moving coil. After this we have second one, permanent coil moving magnet. Okay. So permanent coil moving magnet. Okay. So these are the two types. In this, again, suspended type and pivoted type of galvanometer are there. Suspended means freely movable and pivoted means fixed. Okay. So we have to see suspended type, permanent magnet moving coil. Coil is suspended in this. Okay. So how we say? We have to take like this, two bar magnets. but the shape of magnets is horseshoe. Magnet shape of magnet is horseshoe using this galvanometer. So these are the horseshoe magnets are used in the galvanometer. Okay, in between these two magnets we have to put our coil like this. Okay, PQRS, and which are situated in uniform magnetic field. Okay, along with that we have to connect a helical spring. Okay, here we have put mirror and phosphorus bronze fiber. Okay, so here what is the use of galvanometer? Galvanometer used as a current sensitive device. This is the current sensitive. With the help of this instrument we have to measure the current. Okay, how we have to check the current? So when current pass through this coil, okay, at that time coil is going to turn by that current, because there is a force, because there is a uniform magnetic field, and due to that forces there is a production of torque in this direction. So coil is moving in this direction, and due to that this helical spring going to twist. Okay, so after the current there is a twisted torque is also produced. So first of all, which kind of torque is produced here? TD, that is called as deflecting torque. And after the removal of current, there is another torque is produced because of restoring force of spring, and that torque is called as twisted torque. These two are equal because both are do same work. Okay, so these are the basic things or construction of galvanometer. Okay, after that we are going to discuss about mathematical equation of this instrument. Okay, so for that coil, this is our coil which is put between this. Okay, this is the A and this is the B side. Okay, so this is rectangular coil. The force is acted like this due to the torque. Okay, this is the perpendicular distance between the forces. So we know that according to our last phenomenon, F is equal to what? F is equal to BI, this we have to say L sin theta. Okay, for this force is 0 because field is in same direction to that side. So angle between these two are 0. Length and field, angle between length and field is 0. So that's why the force on this arm is 0. But maximum force acted on this arm, because the angle between field and length L is 90 degree and sin 90 is 1. So F max force we have obtained BIL. We have said equation first. Only we have to say here F. Okay, so these two forces are F because length are same, field is uniform. So same force acted in equal and opposite direction. At that time there is a production of torque. So on which arm these forces are act? Along this arm. Okay, so we have to write the torque TD. So because this is a deflecting torque, and due to this our coil is rotated along the axis. Okay, due to this torque, and which is what? A into F, and F is what? From equation first, A into BIL. Okay, so BI in bracket AL, and AL is the area of our rectangle. So AL is equal to capital A. So deflecting torque is equal to what? BIA. If coil having n number of turns, at that time P is equal to what? NBIA. Then we have to say number of turns. Okay. So this is the deflecting torque. We have to say equation second. After that, we have to find about the twisted torque. We have discussed earlier that after the rotation of deflection of coil, the restoring force is obtained by the spring, and this is released after the removal of current. So there is again one kind of torque is produced, that is named as twisted torque, and which is proportional to the deflection. That we have to say as a theta. Okay, angle of deflection is proportional to theta. So this is the twisted torque, and the constant is c theta. C is twisted constant, that proportionality constant is called as twisted constant. So this is the equation second. So tau c and tau d are equal, and because of that, what we have to say? NBIA is equal to c theta. Hence, we have to find the value of current. I is equal to c theta upon NBA, and all these quantities are constant. C, B, A and N are constant. Hence, current is directly proportional to angle of deflection. So this is the purpose behind this galvanometer. Okay, so this is all about galvanometer. With the help of this galvanometer, we have to convert into two instruments. We have converted galvanometer into two instruments. Earlier we have discussed about these instruments in our current electric chapter. Again we are revising this chapter. First is galvanometer. Is converted into ammeter. Ammeter means it is a current measuring device. Okay, I will measure the current by connecting parallel small value resistor to the galvanometer coil, and this is also called as shunt. Means when we connect a small value resistor parallel to the galvanometer coil, at that time which is converted into ammeter. How? So this is the resistor of galvanometer, and this is resistance which is connected across this. So this is the resistance of galvanometer coil is G, and this is the shunt resistor which having the small value S. The current I is entering in this, and which is split up into two directions. In this direction current is Ig, in this Is. So total current is what? This is I is equal to Ig plus Is. So Is is equal to I minus Ig. So from this we have to find the value of shunt and the okay. So I find the value of shunt according to our rules of series and parallel resistors. When resistors are in parallel, so potential are common at the both the branches. Okay, so potential is same. IgG is equal to ISS. So we have to find S. So we have to convert IS into Ig. How? From this equation first. I minus Ig into S. So S is equal to what? IgG upon I minus Ig. Also from this we know that current is converted into n number of terms. Okay, so how I is equal to n times Ig means n times current pass through the shunt because it having small value. So large current pass through this to avoid the burning of coil. Because जैसे कि हमने पढ़ा है कि कॉइल को बर्निंग से अवॉइड करने के लिए हम स्मॉल वैल्यू रजिस्टर करते हैं कनेक्ट, तो उस वक्त क्या होता है लार्ज करंट शंट रजिस्टर से पास होता है और जो बचा हुआ करंट स्मॉल करंट वो गैल्वेनोमीटर से पास होता है कॉइल से और हमें करेक्ट रीडिंग भी मिल जाता है. ओके, सो दिस इज ऑल अबाउट दिस. So after putting the value of in this equation we have to got the value of N also. How? So S is equal to Igg upon value of I is Nig minus Ig. So Igg upon Ign minus 1. So Ig get cancelled. Yes. So S n minus 1 is equal to G. So Sn minus S is equal to G. Sn is equal to S plus G. So N is equal to S plus G upon S. So these are the some values which are related with ammeter. Important is S and N. Okay. So this is the small value shunt value of resistor or coil. And this is the N times current pass through the shunt resistor. Okay, so this is the conversion of ammeter. After this we have to discuss about next instrument, that is voltmeter. So voltmeter is what? We convert galvanometer into voltmeter when we connect large value resistor in series with galvanometer coil. So when we connect the large value resistor in series with galvanometer coil, at that time galvanometer is converted into voltmeter, and at that time it measures voltage of the circuit. How? So this is the diagram. Okay, we have to connect large value resistor in series with this. Okay, so current is constant in both the branches. We have to say it as a Ig, and voltage is going to split because when the resistor are in series, at that time voltage in going to split across each component. So across this voltage is Vg, across this voltage is Vr. Okay, so Vg is equal to what? Ig into G. And Vr is equal to Ig into Rs. So we have to say it as equation first. After that, total voltage is V from this battery, which is equal to Vg plus Vr. Okay. Then how we calculate this? So see here, V is equal to value of Vg Igg plus Ig Rs. So Ig is common, Ig plus Rs. Okay, we have to find the value of Rs. So after G plus Rs is equal to V upon Ig. So voltage is going to split N times. How? Because V is equal to N times Vg. So large voltage is across this component. Okay, so what happened? So we have to got this equation, V is equal to N times Vg. So we have to put the value of this in equation second. So our equation is G plus RAS is equal to N times Vg upon Ig. And from equation first, Vg upon Ig is G. So G plus RAS. So we have to take G to this side. RAS is equal to Ng minus G. So RAS is equal to N minus 1 into G. So this is the value of RAS. Also, value of RAS is what? V upon Ig minus G. So these are the some equations which are related with voltmeter, and we convert voltmeter into galvanometer into voltmeter. These are the simple equations after using the current electricity knowledge. Okay, so ask some question about this and send me the solved equation of voltmeter and ammeter. So I conclude that these students are see my lecture. Okay, so बच्चों को क्या करना है, आपको ये दो इक्वेशन मेरे पर्सनल व्हाट्सएप अकाउंट पे सेंड करनी है. ओके, कौन से वाले? एक जो है एमीटर का और दूसरा जो है वोल्टमीटर का. ओके, जो नहीं करेगा मैं समझूंगा उन्होंने मेरा वीडियो देखा नहीं है. ओके, थैंक यू.